So, my name is Persson. I work as a security consultant at Omegapoint, and I work a lot with secure development, modern ways of working, and cloud security. And I've just spent the past 3 years working as a team lead for a software security team, helping 300 plus product teams delivering security in their daily work. So today I'm going to talk briefly about DevOps, secure by design, cloud native, and then move over to compliance, assurance, and automated governance. But let's start off with a brief recap of DevOps and the 3 ways of DevOps. For those of you who have read the book Phoenix Project, you might remember that they introduced the 3 ways. So the first way is basically create efficient flow from development to production or operations. That's where the customers are. And the second way is fast feedback. So when you are developing, you want fast feedback, but you also want fast feedback from your customers when you deliver value, if you are delivering value to them. And then the third way was basically creating the culture of a continuous learning. So don't plan too much up ahead. When you know the least, think big, start small, learn fast. And then came the book Accelerate, and it kind of summarized 4 years of state of DevOps surveys where they tried to identify how DevOps teams are working. And they used 4 key DORA metrics, not the DORA we might be talking about today, but the DevOps and research assessment DORAs. They had 4 key metrics. And the first one was basically, how often do you deliver code into production? And the second one was, how long is the lead time from when your developers check in code until that code is in production? And the third one is mean time to recover. So if there is a failure, how long does it take for it to restore operations? And the fourth is, how often do you have a failure? So these are the 4 key DORA metrics. And the conclusion from the reports was basically that the teams that are really, really good at DevOps, they deliver value, more value, faster, and with higher stability. So that's also a paradox. Brian had a paradox as well. So the DevOps paradox, delivering value faster with higher stability. And I really like to use this infinite DevOps loop with the 8 stages, so not left to right, more traditionally. So I use this when mapping out activities connected to modern development, security, and compliance. So they have the 8 stages of plan, code, build, test, deploy, release, operate, and monitor. And if you have an organization that is delivering software, you have one important decision to start off with, and that is to give your teams, your dev teams, 20% of their time to work on technical excellence. And that would include fighting technical debt, keeping software up to date, working on build and test automation, working on security, working on compliance. So that's a super important decision. Give them the freedom to plan 20% of the time to be technical excellent. And then I use this to map out other activities connected to modern developments. We have continuous integration, automated testing, continuous deployment, and releasing without downtime during daytime. So we release software on Tuesdays before lunch when everybody is on site, not the night between Saturday and Sunday. I had the great fortune of working with 2 of the 3 authors of this fairly famous book, Secure by Design. And the story in this book is basically that by doing good design, you get secure systems. So they want us to think about security as just another aspect of quality. But the last chapter is, but don't forget about security. So I spend my days helping teams, DevOps teams typically, to integrate security in their daily work with a minimum of friction. I will get back to this friction part later on. And it's no surprise that I'm a big fan of cloud solutions. So for me, a modern cloud-based solution would be one where the infrastructure is managed by the cloud provider, and we represent the infrastructure using code, so infrastructure is code. We are using platform services, and we use the built-in security in those services. Cloud native kind of allows you to either use container-based solutions, typically Kubernetes, or serverless. And I myself would lean slightly more towards recommending using serverless if we were to build something new. Then we have these two images. They are taken from a presentation from Microsoft. So on the left-hand side, we have all the boxes, all the things you need to master to be efficient and secure. And on the right-hand side, the kind of gray boxes are offloaded to the cloud provider, and then you can spend less, your limited resources on less areas. So that's their kind of take of them helping you offload important stuff to the cloud. So that was the brief DevOps, secure by design, cloud native thing. So now I'm going to move over to compliance and assurance and automated governance. So I want to start off with an observation I have made, and that is basically that there is a gap between how we express requirements and how we maybe not explain how to actually implement those things in the daily work. So I really think we need to mind this gap. I really like this formula as well. So the control requirement is equal to the objective of the control plus the specific context where we apply the control. So there is no one size control requirement that fits all. So this is also something we need to be mindful about. And one example could be the old idea that we don't allow software to auto-update itself from the internet. We want to manage that on our own. And then Google, we talked about Google Android patches. So Google Chrome has a 0-day exploited in the wild patch to be updated. And then when we manage this on our own, it will take 4 weeks, 8 weeks to push out this managed on our own update of this web browser. Another example, if you're in the building of software area, you might have a requirement that when building in the pipeline, scanning for the use of potentially vulnerable open source component, the pipeline should break or fail if it finds a vulnerable component about to be pushed out to production. But that component is already in production. Since the area of security research, they find issues all over the globe, all the time. So that's not really the way to make things be good. So say that we are about to release a really, really critical update to our software. And then this potentially vulnerable component are stopping us from pushing this critical fix out into the production. So that might also be a variation of this lack of context when setting requirements. And if your organization is building software, this could be an interesting thought experiment. So what if Brian went from 8 weeks to 2 weeks? Or say you are going from releasing every quarter to releasing every 2 weeks, or going from every month to every week. There might be requirements and processes in place. Say you need to pen test for every release. You need to have a manual security review for every release. You have a cumbersome change approval board process for every change. These things will create friction. So if you start delivering value faster, and that should be a goal of yours, to deliver value to your customers faster, then you might have to change the way you work with the requirements that doesn't really fit when you start releasing more often. So I kind of mentioned friction. Googling for friction, I found this image. So we have a motion, force of motion in that direction, and a counter force of friction in that direction. So maybe us working in security and compliance, we are the counter force to the flow of value. And maybe we should be. But I really think that we should work hard on minimizing this counterforce to flow of value so that we really try to help out instead of being the naysayer. So compliance then, we have objective compliance versus subjective compliance. So objective would be more proof-based. Maybe we have 100 code repositories and we just call an API and getting that they are all securely configured. Versus the subjective version where we randomly pick 5 out of the 100 asking for a screenshot proving that they are securely configured. So our take on this is basically to combine automated controls with good cybersecurity practices. So the automated controls would represent the quantitative or the objective compliance, and the good cybersecurity practices would represent the qualitative or subjective compliance. So if we have a developer team, for example, they build and deploy their code using a pipeline, and they deploy stuff into a cloud account. So whenever they are building using this pipeline, they are also running these automated controls. And they are publishing real-time compliance reporting back to some dashboard, compliance dashboard. And this dashboard is either used by the team or used by the organization to see the current compliance state. And then we periodically complement this with some kind of review based on some framework. We kind of lean towards on using syscontrols as the framework when we do the reviews. That we are actually working according to the way we want to work. So what would we expect to find on such a compliant dashboard? This is for a team developing software. One thing we want to see them doing is threat modeling. We want them to do threat modeling, and in this case, they've done it fairly recently. And we are also verifying that there are no open tickets from that threat modeling session. The next control is basically that they have configured their repository to require at least one other reviewer of the code they are trying to commit. So another developer needs to look at every code that is committed. They are scanning their code for secrets, so no secrets are allowed to be stored in code or in config files. They are scanning using a software composition analysis tool. That's basically a tool looking for potentially vulnerable open source components. Super important. And in this case, they have 0 critical, 0 high ones, but they have a couple of medium ones. So that's why this control would be compliant with a warning. They are using a static code analysis, a SAS tool. So there are no high ones, no medium ones, a low one, but that's kind of okay. So they are compliant in that sense. And then we want them to do a penetration test every 12 months, but they haven't. So that's why they are non-compliant in this sense. On the right-hand side, we have cloud security score. So all the cloud providers have their own best practices, how you build a solution in a secure way in their cloud. And they typically give you a score out of their control set. So in this case, we have 96% compliance to that. That's green for us. And then the last one, we are looking for a policy in the cloud environment preventing us from using any resources in data centers outside of the EU. And then we are also monitoring that all the resources that are already there are compliant to this control. So no resources in data centers outside of the EU. And this could be an example of how such a team dashboard would look like. So the circles on top are the global things in the cloud. The top left one is the overall aggregated score. So 14 out of 17 things are green, giving 82%, and that's fine for us. And the white boxes are the individual code repositories where the team are building components or applications, where they do the threat modelings or the security tool scans of the code, We want them to do pen tests as well. So then we are also working on some experimental controls. So the first one being no humans in production environments. So we are looking to see that there are no human accounts with the right permissions in the cloud account. The only identity we want to find is the identity of the pipeline that is pushing the code into production. So no humans. They could be readers, or they could elevate themselves into having permissions. In Azure, for example, you have the privileged identity management, the PIM feature. You're allowed to give yourself permissions, but you don't have it by default. And the other one, number of virtual machines. We might say that a modern cloud solution don't need virtual machines. So we want them to be 0. So we are monitoring that they are not pushing any virtual machines into the environment. Or we know that we need 2 of them or 20 of them. And then we set the bar at saying that 2 is okay. So mapping back to this infinite DevOps loop that I like so much. So mapping out the compliance controls into this setup would be teams are doing threat modeling, and we are monitoring that they are doing them and that they have no open issues. They have configured their code repositories in a secure way. They are scanning their code, no issues found. They are doing security tests, negative tests, and they have this cloud preventive control in place, making sure that cloud resources are within data centers in EU, or other things could be forcing encryption or whatever. And then we are monitoring the cloud security score, and we are monitoring the typically built-in vulnerability scans in the cloud environment, making sure there are no vulnerabilities. And they are doing penetration tests, and they have these cloud detective policies as well. We can't prevent everything, so we need to add detective controls as well. So the takeaway, the important decision to give your dev teams 20% of the time to work on technical excellence, fighting technical debt, building and test automation, keeping software up to date, security compliance, and then minding the gap between how we express requirements and guiding them how to actually implement them in the real world. Really looking at minimizing friction. And then look at automated compliance. There are a lot of things that could be automated when you want to verify that things are as we want them to be. And then I'm going to end with recommending this book, Investments Unlimited. It's a fairly new book about a bank who has been fairly successful in the DevOps transformation, but they have some issues with the compliance. So they are basically about to lose their banking license unless they get a grip on compliance. So it's a novel, it's a story, it's a short story, it's a thin book, but it's really nice, a really nice way of showing how you combine modern ways of working in DevOps with security and with compliance. So by that, we have fika unless we...
No, we don't have fika. We have to qualify for fika. An economics professor, when we had Tenta, we had an initial 10 to 15 questions. We have to solve those questions to be able to do the rest of the Tenta.
I'm ready.
So I've got some takeaways. You talked about 3 ways DevOps.
Yes.
We talked about 4 key metrics.
The DORA metrics, the other DORA.
Yeah. And that was to get development to production that is working, I think is the most important word.
Yeah. Flow of value.
You talked about good design creates good security. My note here, be aware for maniacs. I mean managers. You don't know what they do. Context for controls to get requirements. I took your equation and put it backwards. But context is quite important.
Very.
You cannot miss out on context.
That was the point.
And 2 weeks is great. To me, I've lived in that environment. 2 weeks to get something working is great. It's not scary. But you have friction.
Yeah. Mind the gap. Minimize friction.
Then we have compliance, all or something way of saying it. And then we have experimental controls. And then your favorite, the infinite DevOps loop.
Yeah. Not left to right.
So, but there is left, right in that, actually. If you're better at development, you have less in operations. Yeah. And if you've been working in a service desk, you don't want rubbish computer developers doing stuff that is not good enough. Anyway, are we qualified for Fika? No. Are we qualified for Fika?
Yeah.
We are qualified for Fika.